After this, again, you'll pair up, talk about it, then we'll go over it, and then we'll take some more notes, and then we'll do that demo back there with the liquids and the fire. Before I forget, take out table H. We need that right after this. Take out table H. Table H. Just take it over, take it out, put it on your desk. Oops, sorry. We'll get to that. Yeah, I think I'm gonna have to break up that corner. It's just too much talking going on. Not right now.
I think you should move it.
I think you should just duct tape your.
Duly noted. Answer these.
I know how to. Yes.
So again, if you don't want to write it down, that's fine, but you need to answer these in your head. You're not just sitting there waiting for your partner or for me to go over it. Number one, I kind of already went over it,
You did.
but not number two. All right, you should have had at least enough time to formulate an idea, pair up, move those desks together, discuss.
I'll answer number one.
Discuss. I'll give you maybe a minute and a half, 2 minutes. Jake, he's gonna join your group.
So it's probably like sweating, you feel it, like you just shower and you're cold, because the water is taking off you, and when the water comes out, it takes some of that. So once it evaporates off, it takes That's why. Well, that's why. What did you write? I bet it was something stupid. What was it?
Give it to me.
No. You. What did you write that was wrong? I want to hear how incorrect it
Are you bullying people, Trevor?
Trevor's bullying me.
is. I'm not a bully.
Trevor told me I was worthless today.
I don't remember that.
Of course not. I don't remember anything.
All right, move back. Let's discuss together.
Jeez, this is crazy.
Okay. Why liquids only evaporate from the surface? Who's got this one? Amanda, thanks for volunteering. Bonds. I don't remember using the word bond at all today. Let's use a different word. Let's use a different word. Yes, so at the surface, so if we have an example here, and we have some particles on the surface, particles below it, just like the example using you guys. Go ahead, say it again. How come only these at the top can actually break free? You did, but I need a little more. Read what you wrote, or read what you said initially. They're weakest, okay. So at the top, they are the weakest, or they have the least amount. So they are attracted to all the particles below them. Okay, there'd be more particles, obviously, but there's nothing up here. It's just air. So at the surface, those particles have the weakest forces of attraction. These in the middle and on the bottom are surrounded, so they're being pulled in all directions. They're not going to be able to evaporate unless you do what? How do you get the ones on the bottom to evaporate?
Turn upside.
Pour it out.
Pour it out. Who said that?
I did, Willow.
Pour it out. Good job. You can pour it out. What else could you do?
Heat it.
Heat it. Fuego. Now, we'll talk about what pouring out does in a second, but the ones at the surface have the weakest forces of attraction. So the particles at the surface have the weakest, we're going to say slash least, right? Least or less is a better way to say it. Maybe particles at the surface have the weakest or least amount of forces of attraction. So therefore they can break free easier. I think you get it. I think that makes sense.
I get it.
Now, bless you. Gaga. Well, you know what else I want to add here? The particles below the surface, the surface are surrounded and have more forces of attraction, or forces of attraction. So hopefully that makes some sense to you guys. All right. How sweating cools us down? Kieran knows.
Well, it's a cooling factor because evaporation takes energy, so it takes it away from your body.
Perfect answer. Good job. Who in here spilled acetone on their hand in lab? Anybody? And what did it feel like?
It was cold.
Really cold, right. If you spill anything on your hand and it evaporates, it's going to feel cold to you for what he just said. That's a good answer. Good job. So as sweat evaporates, it takes heat energy. What kind of energy do you think it takes with it? There's only two types we've talked about, potential and kinetic. Kinetic, right. Takes heat energy slash kinetic energy, Ke, capital Ke, with it. So it leaves your skin cooler or a constant temp. If we didn't sweat, pretty sure we'd die. I don't know, exactly, but we would overheat, and that would not be good for us. So sweating is very necessary. There's a few animals out there that don't sweat. Does anyone know? No, not people, animals. Well, I guess we are animals.
Penguins.
Pigs don't sweat, right. That's why they have to get in the mud all the time, right, to keep them cool, right.
Why is there a
penguins
saying,
don't
I'm
sweat?
sweating like a pig?
That's a good question.
Oh my
That's
God,
because
Ryan.
they don't.
Because they don't sweat. Yeah, some people have a harder time sweating. It might be a condition. I don't know what that is, but yeah, I have a friend of mine who wouldn't sweat very much. I couldn't believe it. He was like drenched, and he would not be sweating at all. I kept telling him he's gonna overheat and die, but he's still alive. Anyways, yeah, that's important. If you don't know that, I think you should just in life in general forget chemistry. But yeah, it evaporates and it takes energy with it. Now, what other process is a cooling process? So sweating is a cooling process even though you feel hot. And by the way, just to prove this to you, one more thing before that question. If you go outside after you're inside sweating a lot, what do you see sometimes coming off of you?
Losing.
Steam, right. Did you say delusions or illusions? You got delusions?
If it's really hot outside.
So no, I'm saying if it's cold out. Yeah, but anyways, so it's taking the heat with it. Anyways, what other process also does the same thing?
Condensation.
That's the opposite.
Dang it.
All right, forget evaporation though. Another, what is it? Someone just said it. Yep, but there's another process too. Boiling. What's water boil at?
100 degrees Celsius.
So can boiling water ever be higher than 100 in this room? No. Why?
Because it.
What if you turn the heat up?
No, it's evaporating.
Right, the extra heat goes away with the steam. That's an important concept in here. That the water, this water, if I was boiling it, would never go above 100. The steam would take the extra heat, just like this, takes our extra heat, so our body stays about the same temperature, tries to, all right? But it takes the extra boiling water, always stays the same temperature till when? All the water's gone, right, good, good. So hopefully everyone's kind of on board with that. We'll talk more about it down the road. All right, okay, you got table H out. We're gonna get to that in a second.
Oh, yeah.
First thing, if we pour liquids out, so like Willow said, you pour the water out of that beaker right there. Or if I dump this on the floor, will it evaporate faster?
Yes.
I think so.
Trevor says yes.
Yeah, because it's spread out and there's
More spread out.
on top.
There's more what?
Surface.
Surface.
More surface, right. So this surface here is pretty small, wouldn't you say?
Yeah.
If I dumped it on the table, it would try and fill up kind of the tabletop, right?
Yeah.
So more particles would be at the surface if you pour it out. Does that make sense?
Yes.
So what I want you to write, as surface area increases, what else increases? Good. Good. Yes, the rate of as surface area increases, the rate of evaporation increases. Rate of evaporation increases as well. Good. So I just want to make that clear that surface area also plays a role here with how fast things evaporate, not just forces. So something that has weak forces versus strong, yes, that's important. We're going to learn it right now, talk about that right now, but this is also important, okay? I mean, we could do it, but that would be silly, but I mean, you could leave this on the table with the top off. How long do you think it would take to evaporate? A few days, right? But if we just pour it on the floor, it probably would evaporate overnight maybe, right? So we're not going to do that, but you have an idea. So questions with any of this stuff we talked about? All right. So now table H and forces of attraction. All right. So why would we be talking about table H right now?
Oh, because it's vapor pressure.
Vapor pressure, right? Forces of attraction in liquids, and then we're going to talk about table H. All right. So, what do we got for time? All right, good. So, if we go to table H, we have 4 liquids on that table. Please let me know if you need table H. Good. Let me know if you need table H. Some students sometimes don't stay with me. They're scared to tell me, or I don't know what the deal is. But I need everyone looking at table H. All right. So there's 4 liquids: propanone, ethanol, water, and ethanoic acid. I'll give you a bonus point on your next quiz if you can tell me the layman's term for ethanoic acid. You know what layman's term means?
No.
Like the normal, average, everyday term.
Ethanol.
Ethanoic acid. You have 10 seconds for a
Ethanol.
bonus point. Close. 5 seconds.
Orange juice.
Closer. Time's up. Vinegar. Vinegar. Ethanoic acid is vinegar. Vinegar. All right. Lemon juice is acidic. Vinegar is acidic. In chemistry brain, it's close. All right. Sorry. Okay. Here's what you're gonna do. Look at table H, and I want you to tell me which liquid, not out loud, I'll call on somebody, which liquid has the highest vapor pressure at 50 degrees? Which liquid has the lowest vapor pressure at 50 degrees? We're going to write this in our notes here. So, which liquid has the lowest vapor pressure?
Doesn't attraction Yeah.
It does. I was just keeping you guys on your toes there. Which liquid has the lowest vapor pressure at 50 degrees? And yes, I did know that I was going too fast. But some things I don't know how to spell. Sorry, I'm writing it down kind of in reverse. But either way, which one has the highest vapor pressure? Which one has the lowest? Make sure you write it in your notes though, okay? Which liquid has the lowest vapor pressure? And then which liquid has the highest vapor pressure? And then we will explain it underneath here, and then we'll go in the back and do that demo before we get out of here. And we're going to draw a couple pictures.
I love drawing pictures.
All right, good. Next to your questions, draw 2 beakers half filled with liquid.
Next to the question.
Or under it, however you want to, however you roll. So this liquid is in here, and this liquid is in here. So the answers to these questions are the liquids in those beakers, respectively.
I feel like we should know what we have to draw before we write the
Yeah.
questions.
Why?
So then we can
So I
space
can
it
like face
the right way.
That's true.
I had to sign somewhere. Oh, there it is.
I'd
No
be
taxation
really,
allowed.
I'd be really
It's
mad
just
if I was
a
at like the bottom of my page.
Yeah.
It's just a sign.
Yeah, I cross every
But
single
I
Right.
don't wanna.
It says no whining.
It's just a sign.
What is
It's
that?
not a law.
Right. It's a suggestion.
So is
The no whining. Okay, table H.
Table H.
What do you guys got for me? Raise your hands. Willow.
I got for highest vapor pressure at 50 degrees, propanone.
Propanone. Who agrees with her?
Me.
I.
A lot of people. Good. All right. Who have I not talked to really today?
Me.
Nick. Which one has the lowest vapor pressure?
The ethanoic acid.
Ethanoic acid. Very good. Now here's a question for Caitlin. Is there any temperature on that chart propanone doesn't have the highest vapor pressure? Maybe I'll reword that. Is propanone's vapor pressure higher for every temperature? Yes. Is ethanoic acid lower than everybody else? Yes. So those lines never cross. So this is kind of a trick question. The temperature is a little bit irrelevant for this question, but I wanted you to be able to read the chart. So now my next question is, I'll write the answers down. My next question, what are their vapor pressures? So read it now specifically using the X and Y axis there. What is propanone and what is ethanoic acid? So the lowest one is ethanoic acid. And then this one is propanone.
At 50, right?
At 50. We're going to just label what their vapor pressure is. I didn't ask that on the board. But. So I want everyone to look it up first, and then I will go over it. I'm going to say ethanoic acid's vapor pressure at 50 degrees is, what do you think, Alexis? 8, all right, so that's propanone, you mean?
Oh.
Yeah, okay, that's fine. Yeah, propanone's about 82, 83. Would we agree?
Yeah.
Ish? Okay,
Oh.
so propanone's about 82 kPa. Very good. Now, what about ethanoic acid? At 50 degrees, what do you think? Well, you just answered that one. I'll go to somebody else. Riley, what do you think? For ethanoic acid at 50 degrees, what's the vapor pressure? About.
15. Oh, hang on.
Yep, try again. Look it up.
Isn't that 8?
8 or 9. I would say 8 or 9. Yeah, 8 or 9 kPa. Yeah, I do remember that.
8 or 9.
No. Hey. Sure. All right. Bye.
Shit.
Alexis, can you see Miss Corso at the end of class?
Okay.
All right. So yeah, ethanoic acid, I would say about 8 kPa. You guys with me on this?
Yeah.
Okay, good. Why? Not why you're with me. Why are these? Why is this so low? Why is this so high? Different forces of attraction. Who's weaker? Who's stronger?
Propanone is stronger. No, it's weaker.
Let's draw pictures.
Weaker.
I love the pictures.
Let's put a lid. Who's gonna have more vapor particles above the liquid? Propanone. Very good. Propanone has more particles. Draw a whole bunch of dots. Ethanoic acid, draw like 4.
Oh, that makes sense.
It should make sense. What causes vapor pressure?
Colliding.
Of
Particles.
what kind? Vapor particles. If you have a lot of vapor particles, do you have a lot of collisions? Yes. If you don't have a lot of vapor particles, do you have a lot of collisions? No. That's why low vapor pressure, high vapor pressure, this here has strong forces of attraction, strong forces. Here we have really weak forces. So all those liquids that we listed earlier that have strong odors, they have really weak forces. They look like this. Lots of vapor. Lots of vapor. So if it's weakly held, they're going to evaporate very easily. Remember when you were holding hands?
Yep.
Well, imagine you had a real strong grip. That's a strong force. You're not going to be able to be ripped apart very easily. But if you were like Trevor, you weren't really holding on at all, you could rip him away easily. That's a weak force, okay? So strong, low pressure, weak would be high pressure because it has a lot of vapor. Hopefully that makes some sense to you guys. Let's go back and show another example of it. Somebody over there, can you turn that off? Just hit the red thing to stop recording. All right.